Assalamualaikum. My name is Muhammad Ifham Wazuri. For the group assignment project, I was assigned to do question 1A, which is integrate t to the power of 4 ln t dt. First of all, the integration of t to the power of 4 ln t dt. Okay. So we put the u to become the ln t. So the dv will be v t to the power of 4 dt. So we should differentiate the dv. Differentiate the dv, and it will become the integrate t to the power of 4 dt. So the integration t to the power of 4 will be t power of 5 over 5. So the differentiate we differentiate the u, so it will become the du over dt equal ln t. So du equal 1 over t dt. So we put the formula uv minus integration of v du. So we know u is ln t and v is t the power of 5 over 5 minus integration of v t power of 5 over 5 and the du will be 1 over t dt. So we can cancel out the t right here and this one. So it will become ln t to the power of 5 over 5 minus this 5 we can bring right in front of the integration. It will be 1 over 5 integrate t power of 4 dt. So next we bring the ln t to the power of 5 over 5 minus 1 over 5, and we integrate the t to the power of 4. It will become t to the power of 5 over 5. We multiply the 5 and 5, it will become 25. So the answer will be ln t to the power of 5 over 5 minus multiply t5 and 1, we got t power of 5 over 5 multiply 5 it become 25. um, we should put the plus c over here to show that it was the after integration. So this is the final answer of question 1a. Thank you so much.
Hi, Assalamualaikum and good evening. My name is Muhammad Firdaus bin Azli. Okay, for this group assignment, the question that I got is question 1B. Okay, the question is, for question B is integral pi over 3 0 sin x ln cos x dx. Okay, since the question asks to do the solution by integral by part, so we use this formula ub minus integral v du. So we need to get the u first. It is ln cos x and change it to differentiate equal to 1 cos x d over dx. Oops. Cos x. So the answer for this is 1 over cos x negative sin x, then du over dx equal to negative sin x over cos x, because this is a multiple product. Negative sins go to up here, then the multiple. Okay, then we get negative tan x dx. Okay, since we want the du, so dx will go behind them. Okay, for dv equal to sin x, v equal to integral sin x, so v is negative cos x. Okay. Okay, so from the previous slide, we get the answer. We got the answer is du equal to negative tan x dx. Then our v is negative cos cos x. So from here, we'll put the equation into the formula that I told earlier, that's uv integral v du. Okay, so ln cos x negative cos x, because our v is negative cos x, so we just to change the v to negative cos x minus integral negative cos s, then our v negative tan x. dx. Okay, so from here, ln cos x negative cos x integral cos x. Since this is cos and we want to stop it, so just change the negative tan x to the earlier trigonal, that is sin x over cos x dx. So just stop it. So our answer is ln cos x negative cos x plus cos x, because from this integral sin x, integral negative sin x. Oops. So our answer, the answer is cos negative cos x. Okay. Oh. So negative and negatives, then we get positive. But don't forget our the next dx. Oops. Not dx but c plus c. Okay, then since our first question we have pi over 3 and 0, so just change this x equal to pi over 3. So from the equation, ln cos pi over 3, then cos again pi over 3 plus cos pi over 3 plus c. So the answer that I got is 8.698. Then our next x is equal to 0. So ln cos 0 negative cos 0 plus cos 0 plus c. So the answer is 1. Okay, next steps is the last step, which is from the answer that we got, x equal to pi x equal to pi over 3 is, the answer is 8698. Then the other one that's equal to 0, and the answer that we get is 1. So from here we just solve the problem to get the final answer, which is negative 9.698. Okay, this is the final answer. Okay, thank you.
Assalamualaikum. My name is Muhammad Aidil Fahmi bin Razha. For group assignment, I will share my solution for question 2. As for my con- con- as for my solution for question 2 is, the question given is integrate 1 over x square root 4 minus x square by using trigo substitutions to sine theta. First step, as the question given trigonometric substitutions, so I use trigonometric substitutions method to solve these integrations. First step is identify the x that is given in the questions, that is x equals to 2 sine theta. Second step is form a triangle from the equations that we get. in the first step. So it will be sine theta equal to x over 2. So based on the equations, we can form a triangle. The angle will be here. So we will be using as a h for sine, that is O for opposite of the angle, and h for hypotenuse for the angle, for the triangle. For opposite side, based on the equation, we will get x, and for the hypotenuse, we will get 2. As for adjacent side, we will get 4 minus x squared from the questions given. For the third step, I differentiate the trigonometric substitutions that's given in the questions. So it will be dx over d theta equal to 2 cos theta. Rearrange the equations. Dx equals to 2 cos theta d theta. For the fourth steps, I substitute the x with the trigonometric equation given in the questions. So be 1 over x squared 4 minus x squared dx equals to, so it substitutes the x with the trigonometric equations given in the questions. Be so sine theta square root of 4 minus 2 sine theta square dx. Next, solve the square, so it will become 4 sine square theta square root of 4 minus 4 sine square theta. As for the x, we will substitute with the value that we use from the differentiates of the trigo equations. So it will be 2 cos theta d theta. Next, solve the one in the square root first. So I take out the 4 inside the square root, so it will become 1 minus sine square theta 2 cos theta d theta. From the trigonometric identities, we know that sine square theta plus cos square theta equals to 1. So we rearrange the equations, it will become cos square theta equals to 1 minus sine square theta. substitute that into the solution, and we get 1 over 4 sine square theta square root of 4 cos square theta to cos theta d theta. So we solve the square root, will become 4 sine square theta 2 cos theta to cos theta d theta. From this, we know that we can cut off 2 cos theta because it's the same thing, and the term left is integrate 1 over 4 sine squared theta. The term left for the solution is to integrate 1 over 4 sine square theta d theta. Next, we put out the constant, put the constants outside the integrations over sine squared theta d theta. So we replace 1 over sine squared theta with 1 over 4 integrations cos square theta d theta. Then we integrate the cos square theta, and it will become 1 over 4. The result of integration will be negative cotangent theta plus c. From the cotangent, we know that cotangent is equals to 1 over tangent theta. So based on the triangle that we made earlier, that is this, for tangent we know that we need to use tangents equals to opposite over adjacent. So from this triangle it will be x over 4 minus x squared. So the term will be negative 1 over 4 1 over x over 4 minus x squared plus c. We simplify the term and it will become negative 1 over 4 square root of 4 minus x squared over x plus c, and then it will become negative square root of 4 minus x squared over 4x plus c. And that will be my final answer for questions 2. So that's all from me. Goodbye and thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidil and my student ID is 2021899336. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidil Musmadi. I'm going to present question number 3. So, the question given is x cube plus x power of 2 plus 1 over x multiplied by x minus 1 multiplied by x power of 2 plus x plus 1 multiplied by x power of 2 plus 1 and close bracket power of 3. Therefore, in this question, we are going to use a partial fraction, because there are lots of denominator here, and denominator power is the higher than the upper one. So let x to the power of 3 plus x to the power of 2 plus 1 over x or multiplied by x minus 1 multiplied by x to the power of 2 plus x plus 1, then multiplied by x to the power of 2 plus 1 over the power of 3 equal to a over x plus b over x minus 1 plus c multiply x plus d over x power of 2 plus x plus 1 plus ex plus f over x to the power of 2 plus 1 plus gx plus h plus x cubed plus 1 bracket to the power of 2 and plus ix plus j over x to the power of 2 plus 1 close bracket power of 3. This is because we are partial. We are partial the fraction over here. We are divided by parts. Therefore, divide, and got this. Then, we multiply all of the terms with the denominator here. And then we will got this. Moving on, we are going to solve the unknown parameters by plugging the real roots of the denominator, which is 0 and x equal to 1. By plugging in, we will get that a equal to negative 1 and b equal to 1 over 8. We can see over here in the slides, all of the x we are plugging by the 0, and all of the x over here we are plugging by 1. After that, we can insert the new value of a and b, which is negative 1 and b equal to 1 over 8 from previous. Then we expand the equation, then we get cx power of 9 plus ex power of 9 minus 7x power of 9 over 8 plus dx to the power of 8 minus cx to the power of 8 plus fx to the power of 8 plus x to the power of 8 over 8 minus dx to the power of 7 plus 3cx to the power of 7 plus 2ex to the power of 7 plus gx to the power of 7 minus 5x to the power of 7 over 2 plus 3dx to the power of 6 minus 3cx to the power of 6 plus 2fx to the power of 6 minus ex to the power of 6 plus hx to the power of 6 plus 11x to the power of 6 over 8 minus 3dx to the power of 5 plus 3cx to the power of 5 minus fx to the power of 5 plus ex to the power of 5 plus gx to the power of 5 plus ix to the power of 5 minus 9x to the power of 5 over 4 plus 3dx to the power of 4 minus 3cx to the power of 4 plus fx to the power of 4 minus 2ex to the power of 4 plus hx to the power of 4 minus gx to the power of 4 plus jx to the power of 4 plus 27x to the power of 4 over 8 minus 3dx to the power of 3 plus cx to the power of 3 minus 2fx to the power of 3 minus hx to the power of 3 minus x to the power of 3 over 2 plus 2x to the power of 2 minus cx to the power of 2 minus ex to the power of 2 minus gx to the power of 2 minus ix to the power of 2 minus 25x to the power of 2 over 8 minus dx minus fx minus hx minus jx plus x over 8 plus 1. Next, moving on, we are group the elements according to the power of x. As we can see here, the power of 9 we are bracket here, and all the according to power of x power of 8, x power of 7, x power of 6, x power of 5, x power of 4, x power of 3, x power of 2, and x until 1. Then, after we got all of this, we are grouping all this into the list of questions. From all of the equation over here, we can get the 9 of the question over here, which is negative d minus 4 minus h minus j plus 1 over 8 equal to 0. Question number 2, d minus c minus e minus d minus I minus plus 25 over 8 equal to 1. Then question number 3, we get negative 3d plus c minus 2f minus h minus 1 over 2 equal to 1. And question number 4, we got 3d minus 3c plus f minus 2e plus h minus g plus j plus 27 over h equal to 0. Then question number 5, we get negative 3d plus 3c minus f plus e plus t plus I minus negative 9 over 4 equal to 0. Then question number 6, we can get it 3d minus 3c plus 2f minus e plus h plus 11 over 8 equal to c. Then question number 7, we get negative d plus 3c plus 2e plus g minus 5 over 2 equal to 0. Then question number 8, we get d equal to c plus f plus 1 over 8 equal to 0. Then 9, we got c plus e minus 7 over 8 equal to 0. Then from the equation 9, we can isolate c, which is c, we can get c equal to negative e plus 7 over 8 by we rearrange the equation here, and then we substitute all of the c to all of this equation, and here we got, as you can see over here, we insert all of the c with the negative e plus 7 over 8. Move on, we're going to simplify the previous equation, and we get negative 3 over 4 plus d plus f plus e equal to 0, negative d equal to minus f minus h minus j plus 1 over 8 equal to 0, negative 3d minus 2f minus e minus h plus 3 over 8 equal to 1, negative e minus d plus g plus 1 over 8 equal to 0, 9 over 4 plus d minus g minus I equal to 1, 2e minus 5 over 4 plus 3d plus 2f plus h equal to 0, negative 2e, negative 3d, negative f plus g plus I plus 3 over 8 equal to 0, e plus 3 over 4 plus 3d plus 4 plus h minus g plus j equal to 0. As you can see here, all of the c has been eliminated as we have inserted the c of from previous. Then from now on, we can isolate d, which is from the equation negative 3 over 4 plus d plus f plus e equal to 0. Then we can get d equal to negative f minus e plus 3 over 4. Then we can insert here all of the equation from d over here into the new d, which is negative 4 plus e plus 3 over 4. Next, after we substitute all of the value from the previous slide, we have to simplify it. And after we simplify, we can get f plus g minus 5 over 8 equal to 0, 3 minus f minus e minus g minus I equal to 1, e minus h minus j minus 5 over 8 equal to 0, f plus 2e minus h minus 5 over 15 over 8 equal to 1, negative f plus 1, this is plus 1 not plus 1, oh sorry, negative e plus h equal to 0, 2f plus e plus d plus I, negative 15 over 8 equal to 0, negative 2f plus 3 minus 2e plus h minus g minus j to 0. And then, after we eliminate all of d, we can now isolate f, which is f plus g minus 5 over 8 equal to 0. Then we can get f equal to negative g plus 5 over 8. Now we can substitute all of the f by the new f, which is negative g plus 5 over 8 for over here. Now, after we substitute all of the f, now we can simplify the previous question, and we can get e minus h minus j minus 5 over 8 equal to 0, Negative 5 over 4 plus 2e minus h minus g equal to 1. G minus e plus h plus 3 over 8 equal to 0. Negative e minus I plus 19 over 8 equal to 1. Negative g plus e plus I minus 5 over 8 equal to 0. G minus 2e plus h plus j plus 7 over 4 equal to 0. So now, we can now isolate e, which is from the equation negative e plus I, negative e minus I plus 19 over 8 equal to 1. E equal to negative 8i minus 11 over 8. After we solve this, then we now substitute e for all of this question. And now we can get this. After that, after we substitute all of the e, and now we simplify it, and we can get this. Negative 4i plus 3 over 4 minus h minus j equal to 0. Negative 4i plus 3 over 2 minus h negative g equal to 1. G plus I minus 1 plus h equal to 0. Negative g plus 3 over 4 equal to 0. G plus 2i minus 1 plus h plus j equal to 0. As we can notice here, the unknowns and the equations are now getting lesser. Therefore, we can solve it later on. Then, now we can isolate g. Therefore, we can get negative g plus 3 over 4 equal to 0. G equal to 3 over 4. Then substitute g to all of the equation we have left. Then we can get here negative 4i plus 3 over 4 which minus h minus j equal to 0. Negative 4i plus 3 over 2 minus h minus 3 over 4 equal to 1. Negative 3 over 4 plus I minus 1 plus h equal to 0. 3 over 4 plus 2i minus I plus h plus j equal to 0. Now, after we substitute g, we can now simplify it. We can get negative 4i plus 3 over 4 minus h minus j equal to 0. Negative 4i plus 3 over 2 minus h minus 3 over 4 equal to 1. I plus h minus 1 over 4 equal to 0. 2i plus h plus j minus 1 over 4 equal to 0. And so now, we can isolate I. From the equation, negative 4i plus 3 over 2 minus h minus 3 over 4 equal to 1. I equal to negative 4h plus 1 over 8. And then we can now substitute I from the left equations, which is negative 4h plus 1 over 8 plus h minus 1 over 4 equal to 0. Negative 4 bracket negative 4h plus 1 over 8 plus 3 over 4 minus h minus j equal to 0. And then 2 bracket negative 4h plus 1 over 8 plus h plus j minus 1 over 4 equal to 0. And now we can simplify the previous equation. We can get negative 1 over 4 plus 4h minus 1 over 8 equal to 0. Negative j plus negative 4h plus 7 over 8 equal to 0. Then the third equation is j minus 1 over 2 equal to 0. From now, you can isolate h. Negative 1 over 4 plus 4h minus 1 over 1 equal to 0, and can get h equal to 3 over 4. So now we can substitute h. We can get the two left equation, which is j minus 1 over 2 equal to 0. Negative negative j plus negative 4 3 over 4 plus 7 over 8 equal to 0. And after we substitute h, we can now simplify the previous equation. We can get j minus 1 over 2 equal to 0. Negative j plus 1 over 2 equal to 0. Then isolate j. J equal to 1 over 2 equal to 0. And we can get j equal to 1 over 2. So that we can prove it the equal to equation that equal to 0, which is we substitute j, and we can get negative 1 over 2 plus 1 over 2 equal to 0. And yes, we can get 0 equal to 0. So that our equations and our unknown is correct. So that we already got all the value is j. We find j from the previous question, negative 4 multiplied by 3 over 4 plus 1 over 8. We can get j equal to negative 1 over 2. E negative 8, negative 1 over 2 minus 11 over 8. We can get E equal to 15 over 8. F equal to negative 2 over 4 plus 5 over 8. We can get F equal to negative 1 over 8. T equal to bracket negative 1 over 8 minus 15 over 8 plus 2 over 4. T equal to negative 1. C equal to negative 15 over 8 plus 7 over 8. And C equal to negative 1. After that, after we have solving all the previous simultaneous equations, we can now that collect our all the unknowns we have here is D equal to negative 1, F equal to negative 1 over 8, C equal to negative 1, H equal to negative 2 over 4, E equal to 15 over 8, J equal to 1 over 2, G equal to 3 over 4, I equal to 1, negative 1 over 2. And now we can replace over here, which is from the first equation that we have got from the partial equations, x to the power of 3 plus x to the power of 2 plus 1 equal to negative 1 over x plus 1 over 8 over x minus 1 plus negative 1x minus negative 1 over x to the power of 2 plus x plus 1 plus 15 over 8x plus negative 1 over 8 over x to the power of 2 plus 1 plus 3 over 4x plus 3 over 4 over x to the power of 2 plus 1 bracket of 2 power of 2 and plus negative 1 over 2x plus 1 over 2 over the bracket of x plus x power of 2 plus 1 the power of 3, so that we can now get the equation. The partial equation over here is x to the power of 3 plus x to the power of 2 plus 1 equal to negative 1 over x plus 1 over x bracket of negative x minus 1 plus negative x minus 1 over x to the power of 2 plus x plus 1 plus 15x minus 1 over 8 multiply bracket of negative multiply bracket of x to the power of 2 plus 1 plus 3x plus 3 over 4 bracket multiply the bracket of x square plus 1 the power of 2 plus e plus negative x plus 1 over 2 multiplied by the bracket of x plus x to the power of 2 plus 1 close bracket the power of 3. So after we finish the partial fraction, we can now do the integrations. And now we apply the sum rule, which is we separates all the integration, which is by here we can see here negative integrations with 1 over x dx plus integrate 1 over x bracket x minus 1 dx plus integration of negative x minus 1 over x power of 2 plus x plus 1 dx plus integration of 15x minus 1 over 8 bracket x power of 2 plus 1 dx plus integration of 3x plus 3 over 4 bracket of x power of 2 plus 1 power of 2 dx plus integration of negative x plus 1 over 2 x power of 2 plus 1 over 3 of dx. By taking each of the equation above, you can get 1 over x dx equal to ln x. This is from the formula, we can get this. And 2, from this equation, 1 over 8x minus 1 dx, we can get by take the 1 over 8 out of here. And then we can ln this side 1 is 1 over x minus 1. Then for the third equation, negative x plus 1 over x plus 2 plus x plus 1 dx, we can get divide it over by 2, which is negative integrate x over x plus 2 plus x plus 1 dx minus integration of 1 over x plus 2 plus x plus 1 dx. For equation number 3, it is quite complicated to integrate directly. Therefore, we have to use a specific method, which is we have to complete the square, which is x plus x power of 2 plus x plus 1 equal to, we can get x plus 1 over 2 the power of 2 plus 3 over 4. And then we insert back to the denominator. And then we get this. Integrate of x over x plus 1 over 2 the power of 2 plus 3 over 4 dx. And then we can apply the u subs, which is we let the u equal to x plus 1 over 2, and then du dx we can get 1. Then integrate this, we can get x over u squared plus 3 over 4 multiply 1 du and can get equal to 1 integration of 4x over 4 u squared plus 3 plus u of 3 multiply du. Then we can get u equal to x plus 1 over 2. Then we can rearrange it and get x equal to u equal to negative u minus 1 over 2. And then insert the new x, we can get integration of 4 brackets u minus 1 over 2 over 4 u squared plus 3 du. Simplify it and we can get 4u minus 1 over 2 over 4u squared plus 3. And then we can get 2u 2 of 2u minus 1 over 4u squared plus 3. Then integrates 2 bracket 2u minus 1 over 4u squared plus 3 du. Next, integration of 2u over 4u squared plus 3 du equal to 1 over 4 ln 4u squared plus 3. As we can see here, we can change it to the ln, and 1 over 4, we can get it back over here. Then equal to integrates 1 over 4u squared plus 3 du equal to 1 over 2 square root 3 tangent arctangent square bracket of 2 over square root 3u. Then we can get 2 bracket of 1 over 4 ln 4u squared plus 3 minus 1 over 2 square root 3 arctan bracket of 2 over square root 3 u close brackets. And then we can now substitute back u, which is u equal to x 1 over 2. And then we can get 2 bracket of 1 over 4 ln bracket 4 bracket x plus 1 over 2 close bracket plus 3 bracket of negative 1 over 2 the square root 3 arctangent the bracket of 2 over square root 3 and bracket x plus 1 over 2. Then simplify it. We can now get equal to 2 the bracket of 1 over 4 ln 4 multiply x plus 1 over 2 the power of 2 of this bracket here plus 3 the bracket of negative 1 over 2 square root of 3 arctangent brackets 2 over square root 3 bracket of x plus 1 over 2 close bracket. Now we can get equal to 1 over 2 ln bracket 4x square plus 4x plus 4 minus 1 over square root 3 arctangent 2x plus 1 over square root 3. Next, integrates 1 over x squared plus x plus 1 dx can get 2 over square root 3 arctangent square root of the bracket of 2x plus 1 over square root 3. And then equal to negative 1 over 2 ln 4x squared plus 4x plus 4 close bracket negative 1 over square root 3 arctangent bracket 2x plus 1 over square root 3 minus 2 over square root 3 arctangent 2x plus 1 over x square root 3 over square root 3. And then simplify it, we can now get negative 1 over 2 ln 4x squared plus 4x plus 4 minus 1 over square root 3 arctangent 1 over square root 3 2x plus 1. And then for the another questions, we can integrate it by 15x minus 1 over x to x squared plus 1 dx equal to 1 over 8 square root 15 over 2 ln x plus 2 x power of 2 plus 1 negative tangents x. And then for the question number 5, we get 3x plus 3 over 4x power of 2 plus 1 square root 2 dx. And then for this integration, we can get 1 over 4 bracket of negative 3 over 2 x power of 2 plus 1 plus 3 over 2 arctangents x plus x over 1 over 1 plus x squared close brackets, and get 6 over 6. We get integration of negative x plus 1 over 2 x power of 2 plus 1 power of 3 dx. We can get negative 3 power of 4 tangent arctangent x plus 3x over 3 x power of 3 plus c x power of 2 tangent arctangent x plus 5x plus 3 arctangent x plus 2 over 16 x to the power of 2 plus 1 and close bracket to the power of 2. For the question 4, 5, 6 here, I didn't show how the flow specifically because it has been too long of the spending of the time showing all the shows of the steps step by steps. Okay, so now we're moving on to the next slide. Alright, so now we can insert all of the equation that we have integrated from previous slide to this new equation here, which is negative ln x plus 1 over 4 ln x minus 1, negative 1 over 2 ln 4x squared plus 4x plus 4 minus 1 over square root 3 arctangent 1 over square root 3 2x plus 1 plus 1 over 8 15 over 2 ln x power of 2 plus 1 minus arctangents x plus 1 over 4 minus 3 over 2x power of 2 plus 1 plus 3 over 2 arctangent plus x over 1 plus x plus x power of 2 and plus 3 over 4 3 to the power of 4 arctangent x plus 3 power of 3 plus cx to the power of 2 arctangent x plus 5x plus the arctangent x plus 2 over 16 the bracket of x to the power of 2 plus 1 cross bracket to the power of 2. And then we can just simplify the previous equation over there, we see the up this one, and now we can get this equation over here, which is 1 over 4 ln x minus 1 minus 1 over 2 ln 4x squared plus 4x plus 4 plus 1 over 4 arctangent x plus 3 over 8 bracket of x over x squared plus 1 minus 15 over 16 ln x squared plus 1 minus 1 over square root 3 arctangent 1 over square root 3 2x plus 1 minus ln x minus 3 over 8x power of 2 plus 1 plus 3x power of 4 arctangent x plus 3x power of 3 plus 6x power of 2 arctangent x plus 5x plus 3 arctan x plus 2 over 16 power the vector of x squared plus 1 and power of 2. And then we can now add the constants to solution is plus c. So that's all from this question. This is very interesting question because there are so many steps to solve these questions, which is we have to partial question and then integrate it from the sum formula. This is question is very challenging for me. Then what I can say is because of its denominator affects the questions to be very long. Right, thank you. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Azmi Beni Sharifli from class EMK 3M. EMK3M18, and metric number is 2021869054. So today I will explain to you guys how to answer the question 4. So in the question 4, say the rational number 22 over 7 has been used as an approximation to the number pi since the time of Archimedes. So show that integration of x power of 4 1 minus x power of 4 over 1 plus x squared equal to 22 over 7 minus pi. So to solve this problem, first we need to simplify this equation, which is x power 4 1 minus x power 4. So to simplify this equation, first we need to expand this 1 minus x power 4. So when we expand that, we will get 1 minus 4x plus 6x squared minus 4x cubed plus x power 4. And then after that, we will time it with the x power 4. And we will get x power 4 minus 4x power 5 plus 6x power 6 and 4x power 7 plus x power 8. After we simplify this equation, we will put it back to our original equation, which is x power 4 minus 4x power 5 plus 6x power 6 minus 4x power 7 plus x power 8 and divide by 1 plus x power 2. From this equation, we can see that the degree at the top and the degree of the denominator, which show the degree of at the top is more higher than degree of degree in the moderator. So this we can say that this fractions is actually an improper fraction. So to solve this, to integrate this fraction, we actually need to make it a proper fraction by do the log division. So we do the long division like this, and we will get the final answer for the long division is x power of 6 minus 4 x power of 5 plus 5 x power of 4 minus 4 x power of 2 plus 4, and we also get the remainder. Remainder is negative 4. We got the remainder negative 4. So next we get a new new equation, which is x power 6 minus 4 x power 5 plus 5 x power 4 minus 4x squared plus 4 minus 4 over x squared plus 1. So after we get this new equation, we will integrate it. We will integrate it, and we will get the integration of the new equation, which is 6 power 7 over 7 minus 2 x power 6 over 3 plus x power 5 minus 4 x power of 3 over 3 plus 4x minus 4 tan inverse x. And after we integrate it, we need to substitute the x with the 0 and 1, and we will get the final answer is 22 over 7 minus 5. So this is then, so that we have shown that integration of x power 4 1 minus x power 4 over 1 plus x power 2 is equal to 22/7 minus pi. So that's how we solve the problem for the question 4. That's all for me. Thank you.